A z-test is a statistical method used to determine whether there's a significant difference between the means of two groups. It's particularly useful when dealing with large sample sizes and when the population standard deviation is known. The test compares the sample mean to a known population mean and calculates a z-score, which is then used to determine the probability, p-value, of obtaining the observed difference by chance. If the p-value is below a certain threshold, commonly 0.05, the results are considered statistically significant, indicating that the difference between the groups is likely not due to random chance. The suitability of conducting a z-test depends on several factors. Sample size. Generally, a z-test is suitable when dealing with a large sample size, typically n, 30. For smaller sample sizes, other tests like t-tests may be more appropriate. Known population standard deviation. The z-test assumes that the population standard deviation is known. If the population standard deviation is unknown and you are working with a small sample size, a t-test or other methods may be more suitable. Independence of samples. The samples being compared should be independent of each other. This means that the data points in one sample should not influence or be related to the data points in the other sample. Normal distribution. The data in each sample should ideally follow a normal distribution. While the z-test is robust to deviations from normality, extreme departures may affect the accuracy of the results. Research question. The z-test is appropriate when you want to compare means between two groups and determine if there is a statistically significant difference. In summary, a z-test is suitable when you have a large sample size, know the population standard deviation, have independent samples, and are comparing means between two groups.